In this video, we're going to focus on getting the derivatives of trigonometric functions. So let us be guided by these formulas. So the derivative of sine u is cosine u du dx. For tangent u, we have secant squared u times du dx. For secant u, we have secant u tangent u du dx. Cosine u is equal to negative sine u du dx. For the derivative of cotangent u, that would be negative cosecant squared u du dx. And for the derivative of cosecant u, that would be negative cosecant u cotangent u times du dx. So let us try to answer some examples. Let's say we have y is equal to sine 3x. So remember that the derivative of sine u is equal to cosine u times du dx. And in our case, u is 3x. So let us let u is equal to 3x. And then the derivative of u with respect to x is equal to 3. Therefore, the derivative of sine 3x is cosine u. Since u is 3x, this would be 3x times du dx, and that would be 3. So we have 3 cosine 3x. Another example, let's say we have cosecant of 4x squared. So remember that for cosecant, the derivative of cosecant u is equal to negative cosecant u cotangent u times du dx. So in this case, we are letting u is equal to 4x squared, and the derivative of u with respect to x is equal to 8x. Therefore, y prime is equal to negative cosecant of u, that would be 4x squared, and then cotangent of u, same, 4x squared, and then we need to multiply this to the derivative of u, which is 8x. So our final answer would be, we have negative 1 times 8x, so this would be negative 8x cosecant 4x squared cotangent 4x squared. Another example, let's say we have 2 cosine x squared plus cotangent of 2x raised to 5. So the derivative of y with respect to x is equal to 2, and then the derivative of cosine x squared, applying constant multiple rule, plus the derivative of cotangent 2x raised to 5. So we would be needing the derivative of cosine and cotangent. So remember that the derivative of cosine u is equal to negative sine u times du dx. And the derivative of cotangent u is negative cosecant squared u times du dx. We have 2, and then times negative sine x squared, since our u here is x squared, and then multiply this to the derivative of x squared. So we have 2x plus, for cotangent, this would be negative cosecant squared. U is 2x raised to 5. And then multiply to the derivative of 2x raised to 5. So we have 10x raised to 4. So to simplify, 2 times negative 1 times 2x, that would be negative 4x, and then sine x squared. This would be 10x raised to 4 times negative 1 minus 10x raised to 4 cosecant squared 2x raised to 5. So this is now the derivative of the given function. Let's say we have 2x times sine 3x. So in this case, we would be using product rule. So let us have the formula for product rule. That would be f g prime plus g f prime. So let's say f is equal to 2x and then g is equal to sine 3x. So the derivative of f is 2. So to get the derivative of sine 3x, we need to remember that the derivative of sine u is equal to cosine u du dx. So in this case, the derivative of sine 3x is cosine u, which is the given angle, which is 3x, and then multiply to the derivative of 3x, so we have 3. So g prime would now be 3 cosine of 3x. So applying product rule, we have y prime is equal to f, which is 2x, times g prime, 3 cosine of 3x, plus g sine 3x, times f prime, which is 2. So to simplify, we can multiply 2x by 3. So I have 6x cosine 3x plus 2 sine 3x. So this is now the derivative of 2x sine 3x. In this example, we still need to do product rule. So let us have f g prime plus g f prime. So let us have f would be negative 3x squared, and then g is equal to secant 5x. So the derivative of negative 3x squared is negative 6x. And for secant, remember that the derivative of secant u is equal to secant u times tangent u times the derivative of u with respect to x. Therefore, g prime is equal to secant of u, in this case, 5x, tangent of 5x, and we need to multiply this to the derivative of u. So the derivative of 5x is 5. So we can write this as 5 secant 5x and then tangent 5x. Applying product rule, we have f, that's negative 3x squared. G prime is 5 secant 5x tangent 5x plus g secant 5x times f prime is negative 6x. And to simplify, negative 3x squared times 5, that would be negative 15x squared, then secant 5x, tangent 5x, and then we have negative 6x secant of 5x. So this is now the derivative of negative 3x squared times secant of 5x. For this example, let us use quotient rule to get the derivative of the given function. So let's say this is f and this is g. So the formula for the quotient rule would be g f prime minus f g prime over g squared. So if f is equal to cosine x, f prime would now be, remember that the derivative of cosine u is equal to negative sine u and then multiply to du dx. So for cosine x, the derivative is negative sine x, and then derivative of x is 1, so that would be just negative sine x. And let's say g is equal to x squared. So the derivative of x squared is 2x. Therefore, y prime is equal to, so let us follow this formula, g is x squared times f prime, so that would be negative sine x, minus f, we have cosine x, times g prime, so we have 2x, over the square of our denominator. To simplify, x squared times negative sine x is negative x squared sine x. Negative cosine x times 2x would be negative 2x cosine x over x raised to 4. As we can see here, x is a common factor, so we can factor out x. So we have x times negative x sine x minus 2 cosine x over, so this would be x times x cubed. So we can cancel x. Therefore, the derivative of the given function would be negative x sine x minus 2 cosine x over x cubed. For another example, again, let's say this is f and this is g. So the formula would be gf prime minus fg prime over g squared. So if f is equal to sine x plus 1 and g is equal to 1 minus tangent x, therefore, the derivative of f is cosine of x. The derivative of 1 is 0, so it's just cosine of x. And for the derivative of g, the derivative of 1 is 0, and we have negative tangent of x. So the derivative of this would be negative, and then tangent would be secant squared x. So y prime would now be g, that's 1 minus tangent x, times f prime, so we have cosine of x, minus f, that's sine x, plus 1, times g prime, that's negative secant squared x, all over the square of our denominator, 1 minus tangent x. Let us now simplify. 1 minus tangent x times cosine x would be cosine x minus tangent x cosine x. And for this part, this would be positive sine x secant squared x minus secant squared x over 1 minus tangent x squared. Let's say we need to get the derivative of cosine squared 3x. So we can write this as y is equal to cosine 3x and then squared. So we're going to apply chain rule. So again, for chain rule, let us get the derivative of the outside function, leaving the inside function. So this would be 2 times the inside function, cosine 3x, and then we have 2 minus 1. And then let us get the derivative of the inside function, which is cosine 3x. Remember that the derivative of cosine u is negative sine u du dx. Okay, so let us try to simplify this first. 2, and then cosine 3x. 2 minus 1 is 1. And then for cosine 3x, let us follow this. So we have derivative of cosine is negative sine, and then 3x, that would be our u. And then multiply to the derivative of u. So this would be the derivative of 3x, and that would be 3. So simplifying, we have 2 times negative 1 times 3. That would be negative 6 cosine 3x sine 3x. Let's say we need to get the derivative of cotangent raised to 4 of sine x cubed. For this example, we can write this as y is equal to cotangent sine x cubed and then raised to 4. So applying chain rule, remember that it would be the derivative of the outside function leaving the inside. So we have 4 and then cotangent of sine x cubed raised to 4 minus 1. And then multiply to the derivative of the inside function. So the inside function is cotangent of sine x cubed. So we have y prime would now be, let us just simplify this part, 4 cotangent of sine x cubed raised to 3. So we need to get the derivative now of cotangent and then sine. So remember that the derivative of cotangent u is equal to negative cosecant squared u du dx. And the derivative of sine u, that would be cosine u and then du dx. So we have negative cosecant squared, and then we are letting u as sine x cubed. So this would be sine x cubed. And then let us get the derivative of sine x cubed. So let us just copy this part. So the derivative of sine x cubed would be, in this case, our u is x cubed. So let us follow this formula. We have cosine of x cubed and then multiply to the derivative of x cubed. And the derivative of x cubed is 3x squared. So to simplify, we have 4 times negative 1 times 3x squared. So this would be negative 12x squared. And then let's just copy the remaining factors. So this would be cotangent of sine x cubed raised to 3, and then cosecant squared of sine x cubed times cosine of x cubed. So this is now the derivative of the given function. Let's say we would like to get the derivative of this function. So we need to know the derivative of cosine and then tangent and sine. So let us remember that the derivative of cosine u is equal to negative sine u times du dx. For tangent, the derivative of tangent, u, is equal to secant squared u times du dx. And the derivative of sine, u, is equal to cosine u times du dx. And this function can be written as y is equal to, so cosine of tangent sine x squared raised to 2. So as you can see here, we will be doing a lot of chain rule. So derivative of the outside function leaving the inside. So that would be 2, and we have cosine of tangent sine x squared, and then we have 2 minus 1. And we need to get the derivative of the inside function. So we have cosine of tangent sine x squared. To continue, so let us just simplify this. So 2 minus 1 is 1. So we do not need to write this 1. And then the derivative of cosine of tangent sine x squared. In this case, we are letting u as tangent sine x squared. So the derivative of cosine is negative sine. So I would be having negative sine. And since this is our u, let's just copy this. So tangent of sine x squared. And then we need to get the derivative of the inside function. So this would be our u. So I would be having the derivative of tangent of sine x squared. So let us just copy these factors and let us now get the derivative of tangent sine x squared. So let us let u as sine x squared. So the derivative of tangent is secant squared u. So that would be secant squared of sine x squared, since this is our u. And multiply to the derivative of u. This would be your u, sine x squared. So I have sine x squared. So getting the derivative of sine x squared, so this is our formula for sine, that would be cosine u, so that would be cosine of x squared. So this is our u now. And the derivative of x squared, so you need to multiply it to du dx. So derivative of x squared is 2x. And to simplify, we have 2 times negative 1 times 2x. So that would be negative 4x. And let us just copy the other factors. So this is now the derivative of the given function.